Hello and welcome back to Calculus Explained. Today we are going to be looking into the squeeze theorem and trig limits. So this is how to prove limits when algebra can't do it. We've computed limits using algebra, but some limits just don't simplify. Today we learn a theorem that lets us prove a limit by trapping a function between two simpler ones. This also gives us the most important trig limit in all of calculus, sine x over x to 1. So the limit of x is 0, sine x over x equals 1. This is a very, very important limit in calculus. It shows up in derivatives, integrals, and many more places that you will see throughout this course. So a visual of what the squeeze theorem is, trapping a function between two simpler ones to evaluate a limit. For example, if we have these two, and let's say we have a function like this, you can say that even if we aren't able to compute this limit of f of x, we know that this g of x and this h of x, you can compute the limit for those. So what the squeeze theorem is if g of x is less than or equal to f of x, it's less than or equal to h of x, near x equals a, and both g of x and h approach the same value of L, then f must also approach L. So what this is saying is that here at x equals 0, since g of x approaches 0 as x approaches 0, and h of x approaches 0 as x approaches 0, then f of x must also approach 0 as x approaches 0, because f of x is between those two, g of x and h of x. So we can say that the limit of x to a of g of x equals the limit of x to a of h of x equals L, then the limit of x to a of f of x equals L. So, for example, if we have negative x squared is less than or equal to x squared sine 1 over x is less than or equal to x squared, then as x approaches 0, since this goes to 0 and this goes to 0, the middle also goes to 0. Because x squared sine of 1 over x is trapped between negative x squared and x squared. So we are going to prove this limit of x to 0 of sine x over x equals 1 using geometry and the unit circle. So say we have the unit circle, and we have an angle measure x, and we have this right here. oh, sorry, this should be here. So this right here, this smaller triangle is equal to sine x over 2. This large triangle, put it in pink. This right here is equal to tan x over 2, because this value here is equal to 1 tan x. And I'll put this one in purple. This right here, this secant, the area of that is just equal to x over 2. Now, we know that from the visual, sine x over 2 is less than or equal to 1/2 x is less than or equal to tan x over 2. So therefore, sine x is less than or equal to x is less than or equal to tan x. And then we can convert this into the squeeze. So 1 is less than or equal to x over sine x is less than or equal to 1 over cosine x. Therefore, cosine x is less than or equal to sine x over x is less than or equal to 1. And we got this from taking the reciprocals. So now we apply the squeeze theorem as x goes to 0. Cosine x goes to 0. Cosine x goes to 1 as x goes to 0. And 1 just stays 1. So therefore, sine x over x must be equal to 1. So here we've trapped sine x over x between cosine x and 1. Since both bounds go to 1, the middle must also go to 1. Therefore, limit of x to 0, sine x over x is equal to 1. This also is true for the left-hand side from the negatives, because sine x over x is an even function. It's symmetric. So therefore, both sides converge to the same point. Now we can use sine x over x to solve a lot more limits. One example is limit of x to 0 of sine 5x over x. Now to solve this, we can say that this is equal to the limit as x approaches 0 of sine 5x over 5x times 5. Now this will just be equal to 1 by our limit here. So then we are just left with 5, because 5 times 1 equals 5. Now example 2, we can say that limit x to 0, sine x over 3x. We can rewrite this as limit of x to 0 of 1/3 times sine x over x. This will just go to 1, so then we are left with 1/3. Now, a slightly harder example. Limit of x to 0, 1 minus cosine x over x. Now we can use a trigonometry identity. Rewrite this as limit of x to 0 of 2 sine squared x over 2 over x, because 1 minus cosine x is equal to that. And then this is equal to 2 times sine x over 2. Here, we'll erase this to give us more room. Over x over 2 times sine x over 2 times 1/2. We cancel these. Now this limit goes to 1. This you can use direct substitution. You get 0. And 1 times 0 equals 0. So that is the limit. Now, a squeeze theorem non-trig example. We can say limit of x to 0, x squared sine 1 over x. This is the one that we saw earlier in the video. Now, to prove that this is equal to 0, we can say that since sine of 1 over x is always less than or equal to 1 and greater or equal to -1, then you can multiply each side by x squared. So you get negative x squared is less than or equal to x squared sine 1 over x, which is less than or equal to x squared. This goes to 0. This goes to 0. So therefore, this goes to 0. So even though sine of 1 over x is oscillating near 0, multiplying by x squared shrinks it to 0. So let's go through some problems. Number 1, limit of x to 0 of sine 7x over x. Number 2 is limit of x to 0 sine x cosine x over x. Number 3 is limit of x to 0 of x sine 1 over x. And last one, limit of x to 0 of sine x over sine 3x. So pause the video, go through these on your own, and when you're ready, we'll go through them together. Welcome back. So for the first one, it's exactly like this problem right here. You get sine 7x over 7x times 7. This goes to 1, so you are left with 7. Now for the next one, you can separate this into sine x over x times cosine x. This will go to 1, and this will also go to 1. So then 1 times 1 equals 1. Now for this next one, use squeeze theorem. You get negative absolute value of x is less than or equal to x sine 1 over x. It's less than or equal to the absolute value of x. And from here, this goes to 0. This goes to 0. So then this goes to 0. And for the last one, you can rewrite this as sine x over x times 3x over sine 3x times 1/3. This goes to 1, this goes to 1, and you are left with 1/3. So the squeeze theorem, the squeeze theorem is about trapping. the trig limit, sine of x over x goes to 1. That is a foundational limit that you will need to know going into all of calculus. In the next video, we will go over continuity and discontinuity and why limits matter for whether a function is well behaved. I hope this video was helpful to you, and I will see you in the next video.